What if the second server could start with everything the first server already knows? That is the problem an Amazon Machine Image, or AMI, solves. An AMI is a reusable template for launching EC2 instances. It contains an operating system, installed programs, and configuration settings. Think of your carefully prepared server as a finished recipe. The AMI is the recipe you can use again, instead of rebuilding the meal from raw ingredients every time. Here is why that matters. If you configure one server by hand and then repeat those steps for several more, every repetition is another chance to miss a package, change a setting, or choose a different network rule. A custom AMI captures the software stack and settings once, so later instances can begin from the same baseline. The source explains three broad moves. First, launch and configure one source EC2 instance. Second, create and monitor an AMI from it. Third, launch a new instance from the completed image. Notice the wording. The image is a template, not the running server itself. The source instance can be running or stopped, and EC2 automatically snapshots its associated EBS volumes during image creation. We will treat this like an exam method. First, identify the configured source, then create the image. Then wait for the image to become available. Finally, launch from My AMIs. Keep that sequence in your head. One careful setup, many repeatable launches. That is the whole reason AMIs are useful. Let us work the easy case first. A team has one EC2 instance running Amazon Linux 2. The programs are installed, the configuration is tested, and the team wants a second identical server. The tempting alternative is to launch a blank instance and reinstall everything by hand. We do not choose that method because it recreates the risk we are trying to remove. We choose a custom AMI. Step 1, identify the configured source instance. Step 2, create an image from that source. Step 3, wait while EC2 creates the image and its associated snapshots. Step 4, when the status is available, launch an instance from My AMIs. Watch the logic. The source instance supplies the operating system, installed programs, and settings. The new instance is not manually reconstructed. It starts from the captured template. On screen, the left box is the source, the middle box is the AMI, and the right box is the new EC2 instance. The arrow through the middle is the important part. It is the reusable checkpoint. Here is the recipe to copy onto a note card. 1. Select the configured source. 2. Create the image. 3. Wait for available. 4. Launch from My AMIs. A common mistake is to stop after clicking Create Image. That click begins a process. It does not mean the image is ready. The status is part of the method. Practice prompt. You need 3 repeatable EC2 servers from one configured server. What artifact should you create first? The answer is a custom AMI. It is the reusable template between the configured source and the later launches. Now make the first real decision. The source instance is running and handling work. Should you select No Reboot when you create the AMI? Start with the normal path because it protects file-system consistency. By default, EC2 shuts down the source instance, creates and registers the AMI, snapshots the associated volumes, and then reboots the instance automatically. The brief interruption buys you a cleaner capture of the file system. Here is the fork. The normal option means a short interruption, but a stronger consistency choice. No reboot means less downtime, but it may fail to capture pending file system writes. That can leave the resulting image inconsistent. So do not memorize no reboot is better. The correct rule is conditional. Use no reboot only when downtime is not acceptable, and accept that integrity risk deliberately. The wrong path is to see a running server, fear the shutdown, and click no reboot automatically. That decision trades away consistency without checking whether the trade is necessary. After choosing, enter a unique AMI name and an optional description. Then click Create Image. The image may take several minutes, so creation and readiness are separate events. Recipe, select the source, choose Create Image, Give it a unique name, keep the default reboot for normal consistency, use no reboot only when downtime is unacceptable. Click Create Image, then monitor the status. Practice prompt. Which option best protects file-system consistency during normal AMI creation? Allow the default shutdown and reboot. The win is not memorizing a button. It is matching the button to the risk. Before an AMI exists, there has to be a well-chosen source instance. Let us launch one from the beginning. First, choose the AWS region. The source says to choose the region closest to your users, or the one that best fits latency and availability needs. Do not treat region as an irrelevant dropdown. It determines where this instance and the resulting workflow begin. Next, open Services, choose Compute, and select EC2. In the EC2 dashboard, click Launch Instance. Now choose the software image. For the straightforward example, select Amazon Linux 2. This is the starting operating system. The custom AMI will later capture the configured machine built on top of it. On screen, notice the order. Region comes before the launch wizard, and the AMI choice comes before the machine is created. We are not yet choosing a random server and hoping it becomes useful. We are building a controlled baseline. The first launch recipe is choose the region, open Services, Compute, EC2. Click Launch Instance, select an appropriate AMI, such as Amazon Linux 2. Then continue through the wizard. The reason for making these choices deliberately is simple. A later AMI preserves what you configure here. If the baseline is careless, the repetition will be consistently careless. Practice the decision aloud. Where should the source live? The answer is the region that fits the users and the application's latency and availability needs. Start with the right place, then choose the right operating over system image. Now change the workload so the familiar choices become traps. Suppose this source needs more CPU and storage than a tiny free tier-sized instance can provide, and access must be restricted. Do we still choose T2.micro because it is familiar? No. We choose the instance type by the actual CPU, memory, and storage requirements. Free tier eligibility can be useful, but it does not override the workload. Next, look at the security group. The tempting shortcut is to allow broad inbound traffic because it makes testing easy. That is not the rule. Specify the permitted protocol and the allowed IP range for the traffic the instance actually needs. The security group controls traffic. Selecting one does not automatically permit every connection. Track the bookkeeping allowed. Instance count 1. Region, the one that fits the users and availability needs. Network, the chosen VPC and its associated subnet. Authentication, the public key on the instance, the private key stored securely and locally. Storage, choose the EBS type that fits the access pattern, not the type you happened to use last time. Then review before launch. If a later AMI is a reusable baseline, these choices are not decoration. They are the behavior you will reproduce. The harder case recipe is the same chant with a stronger decision at each fork. Choose the region, choose the right AMI, match the instance type to resources, protect the key pair, set count to 1, choose VPC and subnet, narrow the security rules, fit the EBS volume, review, launch. Practice prompt. A workload needs more resources than T2.micro and restricted access. What wins, familiarity or fit? Fit wins. Match CPU, memory, storage, and network rules to the stated need. The source is configured. Now turn that running or stopped instance into the reusable artifact. Open the EC2 dashboard and select Instances from the left navigation. Locate the source instance with the search box or filters. Do not choose a different instance just because it is nearby in the list. Select the configured source, open its action menu, and choose Create Image. The form asks for a unique image name and an optional description. Use a name that lets you recognize the baseline later. Look at what EC2 captures. The AMI records the instance's operating system, installed programs, and configuration, and EC2 automatically snapshots the associated EBS volumes. That is why the storage settings from the launch chapter matter here. This is not merely a label attached to a server. It is a captured template with the volume state included. Now keep the default reboot behavior for the straightforward case. EC2 shuts down the instance, creates and registers the AMI, snapshots the associated volumes, and reboots the instance automatically. The sequence protects file system integrity. Finally, click Create Image. The page may return you to the console while the work continues. Do not interpret the click as completion. The next chapter is monitoring. Copyable recipe. Select the correct source and instances. Choose Create Image. Enter a unique name and optional description. Keep the normal reboot for consistency. Click Create Image. Then check the AMI status. The classic mistake is selecting a convenient instance or assuming the button instantly produced a usable image. Source first, creation second, status check next. Here is the harder creation variant. The instance is serving work and downtime is unacceptable. The fork is now meaningful. You may select no reboot to avoid the automatic shutdown and reboot, but that choice is not a free improvement. Pending file system writes may not be captured in the snapshot. The resulting AMI can therefore be inconsistent. Say the decision in full. No reboot protects availability during the capture, while the default reboot better protects file system consistency. Which one wins depends on the constraint. The wrong path is the absolute rule. Always select no reboot because downtime is bad. That ignores the other side of the trade. If the workload can tolerate a short interruption, keep the default. If it truly cannot, select no reboot knowingly and understand what you are risking. The rest of the form does not change. Give the AMI a unique name, add a description if useful, review the volume information, and click Create Image. Then monitor rather than guessing. Recipe. Select source, choose Create Image, name it, decide reboot versus no reboot from the downtime constraint, click Create Image, verify the resulting status. Practice prompt. Which option best protects file system consistency during normal AMI creation? The default shutdown and reboot. If downtime is unacceptable, no reboot can be justified, but it is the exception because pending writes may be missed. That is the exam distinction. Availability and consistency are different goals, so the button must follow the goal. The image has been created, but it is not ready merely because the request was submitted. Open AMIs in the EC2 left-hand menu. Use the filter Owned by Me so the list shows the custom image you created, rather than unrelated images. Now, wait. The status must change to Available before you launch from it. This status is a gate in the procedure. In the straightforward case, the image becomes available. Select it, click Launch Instance in the EC2 dashboard, and open the My AMIs tab. Locate the new custom AMI and select it. Here is a subtle but important point. The AMI preserves the software and configuration stack, but the new launch still needs launch choices. Complete the wizard again, including instance type, storage, security groups, and other required settings. The template removes repeated software setup. It does not remove every decision about the new machine. Review the settings and click Launch. The method recipe is monitor the AMI, filter to Owned by Me, wait for Available, choose Launch Instance. Find it under My AMIs, recheck type, storage, network, and security, launch. The common mistake is to search the wrong list. My AMIs is the location for your own custom image in the launch wizard. A second mistake is to assume that the AMI forces every new instance to have identical capacity or network rules. It gives you the captured baseline, while the launch wizard lets you fit the new instance to its role. That balance is the payoff. Repeat the known good stack, then make the remaining launch choices deliberately.